Hi guys, today I'm going to discuss about some of the simplest problems under trees. So let's quickly jump in. So one of the questions, which is an easy question under trees, is find if there is a path between two nodes in a directed graph. And a tree is nothing but an acyclic graph, right? So you will encounter this question in trees as well. And so the approach that you're going to use is a DFS or BFS approach, but in a DFS approach, you explore a node in depth before visiting its adjacent vertices. So DFS is better suited for this purpose. And if you remember, DFS uses a recursive stack because it's basically based on recursion. And BFS uses a queue. Okay. And one of the next questions, easy question, is the minimal tree. And they're saying that you have to create a tree from a sorted integer array such that its height is balanced. So one of the clues is the sorted integer array, right? When an integer array is sorted and when you work through the middle of the element, the left and the right become balanced automatically. So using this concept, you're just going to take the mid element and then create a tree node and then recursively call this function for its left and right subtrees. So all elements from start to mid minus 1 will be there in the left subtree, and all those elements which are from mid plus 1 to n will be in the right subtree. Okay, so for finding a path between two nodes, you're using a BFS or DFS, which will clearly show whether there is a path between two nodes. And for creating a tree from a sorted integer array, you're just going to construct the tree from the middle and then expand towards the left and the right. Okay. Another question, which is very simple, is list of depths. It asks you to create a linked list containing linked list of nodes at each depth. So basically, this is also a recursive approach where you pass in the node and the lists of list, which is actually your output list, and then you pass in a level as such. Okay, whenever the level is equal to the listed size, so we create a new linked list and then we add this list to this list and basically add the current node under inspection to this list, which is added to this list. Okay. And for example, when you pass in level is equal to 0 and list dot size would be 0, so equal to, so for level 0 there is no list, so we create a new list, then we add this list to the original output list, and then we add list dot add of the current node. Okay. And if the level is already there, we have a new linked list. In that case, we get that level and then we add the current node under inspection. So it's a simple problem, right? Question. And the next question is check balanced. So this basically wants you to check whether the tree is balanced. A tree is said to be balanced when its height is either -1, 0 or 1. Okay, so basically you have to check whether the height of the trees is not uh, greater than 1, or it's not greater than it's not basically the math dot abs of height should not be greater than 1. Okay, it should not be -2 or it should not be 2. So basically I have to check math dot abs of height should not be greater than 1. Okay. And another simple question is, in order successor of a node given that parent pointers exist for nodes. So if you actually look at a tree, whenever a node, a particular node has a right, then it is going to be the node successor. Whereas if it has no right, then you have to check all its ancestors and you have to reach the ancestor whose left is this node, and that ancestor will be its parent, and that will be its successor. Okay, not a successor. And next simple question is check if a tree is subtree of a given tree. So what you can do is you can have a method which checks whether the given two trees are identical and basically reuse in your recursive function, which basically sees whether the given tree is identical to the tree under inspection. And if not, we have to see whether the given tree is identical to one of its subtrees. Okay. So those are some of the questions which I consider easy. So a recap will be, if there is a path between two nodes, you have to use DFS or BFS. And to check whether a tree can be created, a sorted balanced tree can be created from a sorted integer array. You are using you are expanding from the middle onwards. And list of depth, you're basically creating a linked list of linked list, and based on whether the level is, whether there is a no linked list at that level, or if it is already there, you basically add the current node under inspection and call the function recursively for its left and right subtrees. And for checking balanced height, you have to check whether the math.abs of height is not greater than 1. Okay, and in order successive, there is a right, you're going to return that right, otherwise you go up onto the ancestors until you find the parent whose left is this particular node and return that parent. And to check whether as a tree subtree of another tree, basically check for identical trees, and if the given two trees are identical, check whether the given tree is identical to one of its subtrees. So those are some of questions which I consider easy. So thank you guys. I hope you like this video. Please like this video. Bye.